Okay, so here's our next video on esters. Now there's quite a lot in this, especially in naming the compounds you'll see in a second. So take your time with this, pen and paper, and try to work it out. Pause the video if you need to. Message me if you have any questions. So when we start with esters, esters is a family that ends in an O8. And what we have to do is we have to look at the shape of the molecule. So before this, we were looking at carboxylic acids. Carboxylic acids were C double bond O, OH. That's the way it was written. But if you expanded that out, what you actually found was the OH was actually written like this. The only difference between an ester and a carboxylic acid is in an ester, you don't have that H. You have what's called an OR dash. And at the other end of the ester, you have what's called an OR. And now there's a reason for that. If this was a carboxylic acid, that OR dash would always be H, if it was a carboxylic acid. But in chemistry, you can actually have various endings. So you can have C double bond O, O, and instead of a H, you can have an Na. You can have a C double bond O, an O, and some other compound like CH3. You can have that as well. So as you can see, these groups here at the end are replacing the hydrogen. And that's why your OR dash here is written as that. It's like X in maths. It replaces something else. The OR on the left-hand side here, again, that depends. So if we look at our second example with our sodium, you might have a carbon bonded there. But on the next example, it might be two carbons bonded. So it changes depending on the molecule. And these changes are important because it's the amounts of carbons are going to help us name our compounds. So let's just get rid of this for a second and we'll describe our compounds. So here's what we need to do. When we're working out our esters, we need to look at esters that have two carbons. We need to look at esters that have three carbons. And we also need to look at esters that have four carbons. And we'll take our time going through it. So we'll start with the two carbon ester. So a two carbon ester is going to take this format. So let's say we start with C double bond O and then O. And normally you'd write H if it was a carboxylic acid. But in this particular example, we're going to write CH3. And on this side, it's just a H. So what we've got to do is first of all identify the part of the compound with the ester in it. So the C double bond O and O. So normally what I do for students is we have a look at this group and that's separate to the rest of it. So as you can see, the C double bond O and the O I've isolated from the CH3. When you're naming it, you start with what's surrounded in pink. How many carbons are in that pink box? There is one carbon, therefore this is a meth. Because it takes this format, in other words, C double bond O, O, OR, that means it's an ester. And because it's an ester, this is going to be meth and O8. Now you have to describe what type of ester it is. It's this here that describes the type of ester it is. So in this particular example, this is going to be methyl, methanoate. I'll just get rid of this bit here. So you have methyl, which is the group here, and you have the methanoate, which is what's in pink. Now, if you wanted to keep a count on the number of carbons there, we have a total of 2 carbons, we have 4 hydrogens, and we have 2 oxygens. So you can see we've got a 2 carbon ester in here. C2H4 and then an O2. So let's move on to the next one. We're going to have a look at 3 carbon esters. So I'll be back in 1 second and I'll draw out these molecules. So here's our first 3 carbon ester. So when we're looking at this 3 carbon ester, let's take our time, identify the ester part. So we're looking at the C double bond O and the O. So this part here is our ester part. This CH3 is our alkyl group at the end. So when we're naming it, we start there. Now what's the longest chain of carbon atoms here? It's 2 carbon atoms. So this is eth, and we know it's in an ester format. So this is ethan O8. But what type of ethanoate is it? Well then, that gives us this part here. And that particular part, of course, is a methyl group. So this is not ethanoate, it is methyl ethanoate. And that's the first one. Again, we can take account on that as well. So what have we got? We've got 3 carbons, we have 6 hydrogens, and we have 2 oxygens. So that's the first of your 3 carbon esters. Let's go on to the next one. If we look at this one here, same thing. Let's identify our ester part of the molecule, which is here. And then we have our alkyl group here. Now, a C2H5 group is what's called ethyl. So, going back to our main compound here in the pink square, we've got C double bond OO. So again, we've only 1 carbon in here. This is called meth. It's anoate because it is in the format of an ester. And what type of ester is it? It's an ethyl. So this one is going to be ethyl methanoate. And again, you can do a count on this too. This is 3 carbons. We got 6 hydrogens and we've got 2 oxygens. So looking at these two, C3H6O2, that means that these two here are isomers. They have the same molecular formula, which is these two here. They're the same molecular formulas, but they have different structural formulas, which is over here. In other words, you take the same amount of carbons, hydrogens, and oxygens, but rearrange them in a different way. These are isomers of each other. That's 3 carbon esters. We now have to move on to 4 carbon esters. So, in 4 carbon esters, there is more isomers. So, I'll draw these up and I'll be back in a second. So, moving on to our 4 carbon esters, again, let's identify our ester part of the molecule. So, that's there. So, we're naming this as eth, because it's 2 carbons, and it's anoate because it's an ester, ethanoate. And then we have this part here, which gives us ethyl. So when you're keeping a score of carbons, this particular one has got 4 carbons, C4, and it's got 8 hydrogens, and it's got, 2 oxygens. So in this particular example here, C4H8O2. But there's another C4H8O2, which is down here. So this is also C4H8O2. Except it's put in a different structure. So let's have a look at this structure, which is clearly different. And we'll try and name it. So when we're naming it, we take our ester part, which is the C double bond OO and what's attached to it. In this case, we have an anoate with 1 carbon, which is methanoate. Just 1 carbon just there, that's all. And what type of methanoate is it? It's this group here. This is what's called a propyl group. So this particular one here is called propyl methanoate. And again, that is C4H8O2. But again, there's a third one. And this is also C4H8O2. And it's arranged in a different structure again. Let's have a look at the structure. So identify the ester part, which is this, and then name it. So this again, 1, 2, 3 carbons. So this is prop. You have an ester ending here, so it's prop and O8. And then you have the CH3, which is a methyl group. So this is methyl propanoate. So C4H8O2, C4H8O2, and C4H8O2 at the top. I'm just going to bring the zoom back out a little bit here so you can maybe see them all together. No, zoom back even more. So here are your 4 carbon esters. Because they all have the exact same compound, these ones here are all isomers of each other. Isomers. That is to say, they've got the same molecular formula, but different structural formulas. And you can see that by the names. You have ethyl ethanoate, propyl methanoate, and methyl propanoate. And then, of course, when you mix that in with ethyl methanoate, methyl ethanoate, methyl methanoate, you can see that the esters get quite confusing. But as long as you try to break it up into 2 carbon esters, 3 carbon esters, and 4 carbon esters. So 2 carbon esters only has 1 isomer. Your 3 carbon esters only has 2 isomers. And then your 4 carbon esters has got 3 isomers. So maybe 1 or 2 small little things maybe extra about the structures. Sometimes these structures can be extended. So for example, let's say I take this compound here, propyl methanoate. Sometimes what can happen is this will be extended out like this. So you'd have your C double bond O and your H on the other side. But the C3H7 will be extended out in long form. And again, this is where students can get confused. They don't know where the carbons are. They don't know what the chain is. I would always say to students, just concentrate on getting the ester part of it. And then the rest of it then is your group. And that's the easiest way to name it. Okay, we'll be back in a second with some properties and some uses of esters.